And as of this morning, we have a report that the object got much brighter than expected, much brighter than any previous comet from the solar system did as it approached the sun, perihelion, so to speak. And moreover, the color of the object is blue, bluer than the sun, and that's very surprising because usually when there is dust around an object, it should make it red.
As the sun blazed across the void, something extraordinary began unfolding in the vast silence of space. High above the Earth, coronagraph systems scattered across cislunar orbit picked up something no one had ever seen before, a dramatic color shift in the mysterious interstellar traveler 3I-ATLS. Once glowing with a faint greenish hue like a ghost adrift between the stars, it suddenly began radiating an intense blue light as it swung around the sun at perihelion. This wasn't just a pretty color change, it was physics-defying. The shift suggested temperatures hotter than the sun's own surface, and that's nearly impossible. The sun's photosphere burns at about 5,800 Kelvin, and anything at the distance of 3I-ATLS should be much cooler. In fact, roughly 20 times cooler. By all logic, it should have turned redder, not bluer. Yet, nature had other plans. Or perhaps something else did. This kind of behavior has no precedent in the history of comet observations. Every known model predicts the opposite. As an object gets closer to the sun, it should scatter shorter blue wavelengths and emit longer red ones. But 3I-ATLS flipped the rulebook. Multiple coronagraphs detected it radiating predominantly in blue spectral bands, as though it were generating its own internal heat, surpassing even the sun's surface temperature. Harvard astrophysicist Avi Loeb quickly recognized the gravity of what was happening. He officially classified this strange event as the 10th major anomaly associated with 3I-ATLS and posed a question that sent shockwaves through the scientific community. Could this interstellar visitor possess an active thermal management system operating at temperatures that exceed those of natural stars? It was a bold question, one that dared to step outside the boundaries of traditional astrophysics. As Loeb himself said, he wasn't trying to prove the impossible. He was simply determined to gather enough evidence so that the anomalies couldn't be quietly brushed aside. "That's my motivation," he explained. And he succeeded. His challenge has sparked a global debate, captivating scientists and enthusiasts alike. Everyone wants to know, what exactly is this object that's rewriting the laws of physics before our eyes? The goal is simple, to collect as much data as possible until, as Loeb poetically put it, we finally understand who our cosmic dance partner really is. From a physics standpoint, the mystery deepens even further. According to Wien's displacement law, hotter objects emit bluer light, while cooler ones glow red. So for 3I-ATLS to move from a greenish glow to deep blue radiation under the sun's relentless heat means it's behaving like a source of energy, not a passive chunk of rock and ice. Think about that. A comet that gets hotter and bluer instead of cooling and reddening. Something is very wrong, or perhaps very advanced. On October 29, 2025, 3I-ATLS reached its closest point to the sun, enduring an estimated 770 watts per square meter of solar radiation. During this time, it was hidden from Earth's direct view, perfectly aligned behind the sun since October 21st. But even in its concealment, 3 spaced coronagraphs continued to watch, documenting every flicker and flare of its strange transformation. What they captured could redefine how we understand interstellar objects, and perhaps hint at a technological intelligence far beyond our own. Out there in the silent glow of space, something astonishing is unfolding. Something that even seasoned astronomers are struggling to explain. 3 powerful observatories, Stereo A, SOHO, and GOES-19 have been tracking the interstellar traveler 3I Atlas with pinpoint precision. From its forward position ahead of Earth's orbit, Stereo A's COR2 platform caught the early phases of its approach. Meanwhile, SOHO's LASCO system, stationed at the Sun-Earth Lagrange point, L1, provided round-the-clock monitoring. And the newest addition, JWST-19's COR2 instrument, launched in 2024, delivered an unprecedented level of detail, resolving even the fine structures dancing across the object's surface. When scientists compared all this data, a chilling realization emerged. 3I Atlas isn't behaving like any known comet. Physics tells us that comets nearing the sun should redden, not turn blue. This is because shorter blue wavelengths scatter, while red ones pass through more easily, a basic principle known as Rayleigh scattering. Moreover, comets are cold compared to the sun's blazing photosphere. They radiate mostly infrared and red light, never the brilliant blue we're seeing now. So what's happening here? When asked whether this strange glow might increase the odds that 3I Atlas is something artificial, Dr. Avi Loeb responded with quiet conviction. "It's now a bit above 4, he said, referring to his personal estimate on a 10-point scale that measures the likelihood of intelligent origin. Before the color shift, it was just a 4, but now with the deep blue emissions, that number is rising. Back in August, 3I Atlas displayed the typical green-red hues expected of comets, nothing out of the ordinary. But during perihelion, that all changed. The coronagraph images captured a dominant blue signature, something fundamentally different, something that doesn't align with any known model of cometary physics. According to Loeb's technical breakdown, this chromatic shift represents a startling anomaly, one that forces scientists to reconsider their understanding of thermal behavior in space. His question cuts straight to the heart of the mystery. Is 3I Atlas generating its own internal energy, producing heat levels that surpass even the surface of the sun? If that's true, we could be witnessing technology capable of managing thermal conditions hotter than any natural star, a level of engineering far beyond anything humanity can currently achieve. The data paints an eerie picture. The coronagraphs show a brilliant halo surrounding the object, an envelope nearly 300,000 kilometers wide, comparable to the distance between Earth and the Moon. This matches earlier detections of a massive carbon dioxide plume seen back in August, now intensified beyond expectation. The object's brightness is increasing at a rate far higher than any Oort cloud comet ever recorded, and yet no one knows why. Every attempt to explain it with known physics hits a dead end. The mechanisms behind this surge in luminosity remain completely unknown. Across the globe, radio observatories are now working in unison, scanning the skies for any sign of structured radio transmissions, infrared bursts, or trajectory deviations, anything that might suggest propulsion, communication, or controlled behavior. In the meantime, congressional oversight committees in the U.S. are reportedly preparing to declassify high-resolution imagery from October 2nd, footage that may reveal surface details and structural elements hidden from public view until now. And here's the thing, this isn't just another strange comet story. This marks the 10th recorded anomaly linked to 3I Atlas. The list keeps growing. The first anomaly was its unnervingly perfect alignment within 5 degrees of the ecliptic plane, a trajectory that mirrors the paths of planets and spacecraft, not random interstellar wanderers. Each new revelation feels like another clue in a cosmic puzzle, and the picture that's emerging might change everything we think we know about what moves among the stars. No one expected this. The odds were barely 0.2%, almost impossible. Yet here we are, watching something that defies every known rule of cometary behavior. In July and August, instead of ejecting material away from the sun like every comet we've ever studied, this one did the exact opposite. It threw matter toward the sun. That single fact alone had scientists staring at their data in disbelief. But then came the third revelation, its chemical fingerprint. When researchers examined its spectrum, they found an unusually high amount of nickel compared to iron. That ratio didn't match anything cosmic. It matched something manufactured, alloys you'd find in engineered materials on Earth. And if that wasn't enough, its path through space traced back to the exact same coordinates from which the legendary 1977 WOW signal originated. Two events, separated by nearly half a century, now seem to whisper the same story, that something out there may be trying to make contact. As the analysis continued, they found more peculiarities. This so-called comet was almost completely dry, only 4% water when comets typically carry over 80%. It was as if this object had been stripped clean, or perhaps built that way. Then came the color shift. Observers saw it transition from a faint green glow to a vivid blue, a thermal signature scientists could barely explain. When they ran the math, the combined probability of all these anomalies happening naturally came out to less than 1 in 10 quadrillion. That's about the same as winning the biggest lottery on Earth 15 times in a row. And yet, it's happening right before our eyes. Most people won't even realize how big December 19th, 2025 will be. On that day, 3I/Atlas will make its closest pass to Earth. The James Webb Space Telescope will turn its powerful infrared gaze on it, while Hubble captures its surface in extraordinary detail. Dozens of observatories, from NASA to private research facilities, will be watching together. It will be the most ambitious observation campaign in the history of astronomy. Current models predict the object's brightness will surge, perhaps glowing more intensely than ever before. That blue light, the one no natural object has ever shown so vividly, might hold the answer we've all been waiting for. Astrophysicist Avi Loeb says it best. If this thing is producing heat hotter than the sun's surface, we could be looking at a technology far beyond anything humans have ever built. He insists we must take this possibility seriously, not because it proves alien life, but because it could redefine our understanding of what's possible in the universe. You see, natural objects reflect and re-emit the sun's warmth at cooler, redder wavelengths, but artificial or active objects, ones that generate energy from within, emit at higher, bluer frequencies. That's how you can tell something alive or powered apart from something merely drifting. And 3I/Atlas, well, it's glowing bluer every day. No interstellar visitor has ever behaved like this. Oumuamua baffled us with its mysterious acceleration without any outgassing. Borisov, the one that followed, seemed perfectly normal. But 3I/Atlas? It breaks every rule. It's an enigma, part comet, part machine, part question we don't yet know how to ask. What makes this truly breathtaking is that it's happening now, not in some ancient data set or distant galaxy, but right here in our solar system. We're watching it in real time, with telescopes capable of seeing every flicker, every color shift, every unexplained pulse of light. The world's top scientists, space agencies, and even amateur astronomers are uniting to observe it. Military and civilian sensors alike are tuned to its path. Everyone, from NASA to small backyard observatories, is looking up, waiting to see what this visitor will reveal. Because if 3I/Atlas turns out to be more than just a rock, it could change everything we know about life, intelligence, and our place in the universe. And now, as the world's telescopes remain locked on this mysterious traveler, scientists are narrowing their explanations down to just 3 possibilities. The first, that there's an undiscovered branch of natural physics at work, something beyond our current understanding, something that doesn't fit into the equations written in our textbooks. If this is true, it means the universe still holds fundamental laws we haven't even begun to imagine. The second, that we're witnessing the most extreme statistical coincidence in modern astronomy, a perfect storm of improbable factors that by sheer cosmic chance happen to align all at once. Every data point, every strange reading falling into place not because of intent, but because the universe sometimes likes to remind us how little we know. And then there's the third possibility, the one that makes even the most rational minds pause, that this object, 3I/Atlas, is not entirely natural, that it could be technological, built, designed, manufactured by something or someone beyond our solar system. If that's true, we're not just studying an anomaly, We're staring at proof that we are not alone. Each explanation carries world-changing consequences. If it's new physics, our scientific foundations will have to be rewritten. If it's a rare statistical outlier, it will show just how fragile our understanding still is. And if it's technological, it would answer the question humanity has whispered into the stars for centuries. Are we the only ones? Right now, the mysterious blue glow continues to appear in the data, seen clearly through coronagraph streams. NASA's Stereo A spacecraft keeps a constant watch as 3i over Atlas emerges from its closest point to the Sun. The SOHO Observatory records every pulse and fluctuation, while GOES-19 collects the most detailed measurements ever captured from such an object. Somewhere within these endless streams of data lies the answer, hidden in the light of a single impossible photon. December will bring clarity. Until then, every image, every number, every faint blue shimmer brings us closer to understanding not just this object, but our place in the cosmos. Because make no mistake, whatever the outcome, this moment is reshaping science in real time, and the impact won't stop here. It will ripple outward, transforming how we build our telescopes, how we design our space missions, and how we prepare for future interstellar visitors. The truth is coming, and when it arrives, it may redefine everything humanity thought it knew about the universe and about itself.